Hello everyone. Let me start by saying thank you for being here. I know it's Saturday, I know that it's relatively early, so thank you so much for joining us. And before I start, I just want to give a big round of applause to all of you that wake up early and are here. So, giving the same round of applause once again for our amazing organization that pulled this event. And for me. So I guess you're well wake up, right? Okay? Alright, so let's start a bit. Today I'm going to talk a bit building inclusive AI experience with sign language and generative AI. And if you want to say this title with sign language, with American Sign Language, it's like this. I've got these avatars in a couple of slides just for you to see how complex it can be to speak with sign language. Hola! Before we start, just a brief introduction about me. So my name is Mota. You can find me on all social networks at Mota. I've been developing for Android since the beginning, something like 15 years ago. I love to travel, photography, and running, and I'm really happy to be here at GeekSessions. It's going to be my first edition, and I've heard really well about GitConf, so I hope to find you all after at the bar, so we can have a glass together. So let's talk a bit about sign language and why this is a complex topic. So sign language is a visual manual language that you can use your hands, you can use your body, you can use your mouth to communicate. There's not an universal sign language, so we're in Portugal, so it's the Portuguese Sign Language, LGP. If we're in America, it's the American Sign Language. If we're in Britain, it's the British Sign Language, or the British Sign Language. Italian, Spanish, each one of these countries has its own sign language. So it's like learning a new language. Out of curiosity, almost all the slides here, or all the slides here, unless they say that it's in Portuguese, they are created using the American Sign Language. Just let's see a brief example. So we've got sign languages for gestures, which means for words, and sometimes there's not a gesture for that specific word. And in those cases, we need to use letters. So if you look at the American Sign Language, and if we want to say A, it's like just an open fist. But if you go to the Portuguese Sign Language, it almost seems that we're doing, you understood it. So you can see it's different from language to language, and if you go, of course, to Italian, it's a bit more similar to the American Sign Language, although the end is the opposite, and the rest of them are totally different. Out of curiosity, I've made this joke in Italy, and I just had a slide with this. And basically it's valid for all the letters on the alphabet. So imagine that we want to say hello, and we didn't add a gesture for it. We will do something like this. We're going to use each one of the letters in order to say the word hello. So we will do this for H, for E, for L again, and finally for O. However, since this is a word used quite commonly, there's also a gesture for it. However, if we now go to different languages, it can be identified a bit differently. So something as simple as hello, in American Sign Language you do it like this. If you go to Portuguese, you're a bit shy, so you do it something like this. And if you go to Italian, you're once again really happy about it. So this means that we need to try different models with all of this knowledge. And this is something as basic as trying to have an hello. By the way, all of these avatars are available on @SignNT, even for Portuguese language. Although it's not as complete, it can create and generate your own avatar based on Portuguese words. So let's talk a bit about the challenges. So first we've got the linguistic complexity. It's not just gestures, it's your facial expression, your mouth, your body movements. Once again, you've got multiple sign languages, so we need to train for different languages. Then you've got a couple of other things. So let's make an exercise. Let's all look at our hands. Okay, let's all look at them. Now look at the person next to you, his or her hands. So all the hands are different. So if we wanted to train something, we would need a vast data set with different hands. And it's not only the hands that matter. It's, for instance, if I'm here and I've got light, my hands are lighter. If I'm here and it's darker, it's going to be a different set needed. Once again, the hands are different. We've got different angles. Imagine that we're recording. The distance from the camera is different from being here or from being here. So we need to take into account all of these things. What creates this is a really complex task. Out of curiosity, Google announced this, SignGemma. This was going to be released later last year. That didn't happen. And so far, they don't have a published date for this. So even Google is striving to understand how is the best way to do this. I don't think that my idea works better. No, totally different. I'm just showing a solution that I've created. So I've created a project for this. I created GenAI, once again because Google's approach is focused on American Sign Language, and I wanted to understand the complexity of training my own model in order to understand the Portuguese gestures. Okay? So at this moment, my model is capable to understand the mouth and the hand gestures. Okay? It doesn't look at the pose like Google does, but Google has a big team of workers working on it, and I'm just a single guy working on it part-time. So this is the app that I've built. I've made this test for an Italian presentation, and basically I was asking for the weather, and it says that the weather was fine. It was like 16.3 degrees. Then I've asked it to translate this word for Italian, and it understood the translation, and it said it in Italian. And then, because once again, I'm funny, I tried to do the same thing with your hands, and it also understands as well. I translate the translation mechanism and translate it again to Italian. And by the way, when I did this, this took me roughly 10 minutes to be able to understand this type of gestures. So the tools that we now have available are really fast to train gestures that we want. Basically, we just need to have time to record them. So let's try to understand why this is a complex task. So the first attempt that I had was I wanted to have a video generated on VO3 or on Sora to have something said in sign language. And this was a really complex task. It felt miserable. So basically I just asked someone to wave. And this way I've got an hello in video. So if we understand this video, and let's assume that this is a normal video, it's full HD, we're talking at 2 million pixels. And now if we think that we've got 3 different colors, we're talking about 6 million pixels. And if we're talking about 30 frames per second, or even 60 frames per second, it means that we need to process a lot of pixels in order to understand what the person is saying. And mostly because we want live video and trying to understand gestures in real time. So, if you look again at the image, and you've got a frame of the video, most part of that video is irrelevant. I just want to care about the hand. I don't want to know that person's sweater. I don't want to know the background. I don't know anything. The first attempt that I did, or that I've made to try to replicate an hello gesture, I was really happy with the results until I realized that it was only working with that sweater. So when I trained my model, I thought that he was understanding the hello. No, he understood that I was wearing a blue sweater. And basically the next day I was wearing a different sweater and it didn't work. And it took me a lot of time to understand that the problem was that he understood that the sweater meant hello and not the waving gesture. Also, once again, the proximity. So if I'm making the gesture like this, it's totally different that I'm making the gesture like this. So I'm closer to you, and it's a bit weird because I'm too close now. Come back a bit. Also, the lights will affect if I'm making the gesture here or on top. All of those things will affect the end result. So we need to have in mind that to train with images, we would need something like hundreds of different hands, different backgrounds, different light conditions, multiple camera angles, different hand size, skin tone, shape, whatever, in order to understand what a specific gesture is. So, really good luck with that. However, there's more powerful mechanisms that we can use, and one of these mechanisms is called landmarks. Out of curiosity, who here knows what landmarks are? Okay, nice. So, landmarks are the monuments that we have here in Faro. So, landmarks are used to identify specific features. It can be to identify your face, your hands, your pose, almost anything that you have. So if we look at this image that we've got a person wave, if we're going to apply a thing that I'm going to show you afterward, which is called the hand landmarks for MediaPipe, what's going to happen with this image is that it's going to focus on the hand itself, because it's capable to recognize a hand, and it's going to ignore the rest of the image. Now it knows that a hand has 21 landmarks. Basically, if we look at our hands, we can see that all of these moving parts, all our articulations, it's a single point. So if we record our hands, it's capable to understand the hand movement. Even if you do something like this, and you just cover one of the fingers, it's capable to infer where that finger is. Of course, with less certainty, but since it's aware of how a hand looks like, or all the landmarks in a hand, it's capable to infer that you're just covering one of the fingers. So it will identify the 21 dots, and with this you can know for certain that that person is waving. So what does this identification mean? So each one of these points has x and y coordinates and has the meaning of depth. So if the hand is on the back or it's on the front. We also have the visibility, so if it's not visible, why? And it also defines if you're using your left or right hand in order to understand specific gestures that you might do. So there's a really cool tool called with the MediaPipe, and MediaPipe is organized into 3 different categories. So the first one, So let's start. MediaPipe is an open source framework, it's cross-platform, it means that you can use it everywhere. You can use it on the web, on the mobile, anywhere you like it. And basically it has computer vision and machine learning on your apps. And the most important part here is that it supports live video processing. So I can be recording using MediaPipe, and I can record images, I can record the landmarks, and this is really helpful to train the model afterwards. So it already comes with the pre-trained models. So imagine that I'm using the hand landmarks. I don't want to train an entire model to discover the 21 coordinates of my hand. I can use one of the ones that are already available. So you can have it on 3 different categories. So the first one is tasks, and this is the part that we've got our API that's capable to understand, okay, you're showing your hand and you're waving, or you're not showing anything, or for instance, there are people using this for exercises at home that's capable to understand your pose and seeing if you're doing the exercise correctly or not. And these tasks, these are just a few of them. Basically, they do all of this heavy work for you. All of these tasks are capable to understand if your face is visible, if your mouth is open, if your eyes are closed, if you're saying thumbs up, if you're waving, and whatever. And all of these tasks are available for free, and you can use it freely on your apps. Then you've got the MediaPipe Studio. And, before talking about MediaPipe Studio, so how does this work? Imagine that I want to use the hand landmark. So it's going to look at this image. Once again, it's going to detect that it has a hand. Okay, this is done automatically. Basically, you can see that you've got a model to detect the hand. You've got a second model to detect all the landmarks on your hand. And then you're going to map these coordinates. And then finally, you've got a 4th model that's going to match it with the word alone. All of this is done inside of this task file that contains multiple models that were trained by Google and that you can use and you can expand if you want. But we'll go over it a bit later. Also, there is a really cool talk on YouTube about how everything works here. If you want to see on the point of code, and I know showing code it's always scary, but this is really simple. This is what you need to do on your side. If you want to detect a hand, you just need to implement this callback, this interface, and basically every time that a hand is detected, you're going to see on the results saying that a hand was detected, and if it has an assigned word or not. So basically, you receive a bundle, and if we're going to the first element on that bundle, it's just going to say, in this case, the word hello with a score of 0.6. So, talking about the studio is great because it's a web page that you can check and visualize and test your models. For instance, you can access via this link, and you already have all of these tasks available. Out of curiosity, and because I always wanted to show my dog on stage, I've made this test with my dog that for a brief moment he thinks it's a person. But as you can see, it's capable to understand that I'm a person. And sometimes my dog is also a person. And that I have two books on the shelf. You can play a lot with this. You can import your own models, you can play with it, and you've got already an interface, so you don't need to build an app for that or a web page for that. Finally, you've got the model maker. So basically, you have all of these tasks, and these tasks are trained with millions of images or millions of landmarks, and they only have a set of specific things that they can identify. For instance, they can identify thumbs up, thumbs down, victory, love, stop, things like this. It's like 5 or 6 signs. If you want to train it for a wave or having something like this, you can use Model Maker to extend the existing model. Okay? So how can we train a model? There are multiple ways to do this, and in this case we're going to talk about the two of them that have better results and are faster to implement. So we've got two ways to train a model. The first approach is using static images, and what we're doing here is we're going to use MediaPipe for this, and for static image means that I want to train for a specific letter. I want to train for A, for instance, or in Portuguese it's like this. Once again, wrong finger. And basically we're going to give images to the MediaPipe in order to train it. The problem with this is if we want to do something like a waving, it's not going to work because it only works with still images. This is great once again for letters, for transit signs, for things that don't vary in time, but it's not great for video, for things that have a period of time that they needed to be processed. For dynamic things, the best approach that we have is scarce LSTM, which means long, short time memory, and TensorFlow Lite, so it can run on a mobile device. This is ideally for gestures because it can track, for instance, if I'm doing this, it's going to take 1.5 seconds, it's going to have in memory the landmarks for 1.5 seconds. In this case, the input should be landmarks, so everything that you saw with your hand that you had at 21 points are going to be the information that you're going to send to train your model. Typically, you use 50 frames. This is basically a matter to try to optimize the complexity that it takes and the time that it takes to train a model, and at the same time, the time it takes to record a gesture. So we need to do a bit of balance between one and the other, and 50 frames, basically it's the defined value to be the most precise one for the results that you want. So let's talk a bit about the static approach, and this is done on the project that I've shown you. So basically you can use the Android device, and this is the code that's there, and you're going to use a thing called the preview. Anyone here develops for Android? Oh no. Okay, I wasn't expecting this.
Native count?
Yeah. Okay, who develops for mobile? Okay, so I'm going to start another talk. Why it's important? you developers? Are you developers? Prompt engineers? Okay, so Android allows you to do a cool thing, which is you can have direct access to the images from the camera. It's done via a thing that we call the preview view, and then we can define an interface called the image analysis. The image analysis means that you're going to receive each one of the frames of the camera, and you can process them as you want. This is done really simple by just a few lines of code. So if you want to go to Android, this is easy. And what happens is, so when we receive on the static approach, so when we want to use MediaPipe, what happens is, if we want, when a frame is received, basically we're going to save it as a bitmap, and we're going to record 50 frames, 50 bitmaps that we're going to use to train a model. Okay, so basically just need to click a button, it's going to fire 50 times, and I'm going to use that data set to train the word the letter A or B or C or whatever. This is done statistically. So you need to train a lot of things. So the alphabet has 26 letters if we think generally. So I would need to have 23.50 combinations. And ideally I would have different hands, so it's going to be a large data set that you can be organized by folders. So then you export your data sets, and then there's a really cool tool named Collab. Anyone used Collab? Okay. So Collab is basically, it allows you to train your models on the cloud. It's free-ish, meaning that you can use a lot of, depending on the size of that you have, you can use Google CPUs and GPUs for free. If you've got a lot of information that you need to process, it has it has a bar that you cannot surpass, and otherwise you need to pay for that for more storage. Yeah, it was built for machine learning and data analysis. So it's basically this. Basically, you can import your data set here, and then on the right you can run your Python script, execute it, and you're going to train your model. How does this work? Basically it's Python, so you just need to unzip your folders, and then to train the model you're going to use a thing that is really cool called transfer learning. So I mentioned before that you've got hand landmarks, so you've got a specific task that's going to understand your hand and the 21 points of your hand. And that specific task already has a couple of still images trained. Okay, there are millions of images there, but there are a couple of ones that already have a meaning. So they have the thumbs up, the thumbs down, they've got the victory, and they have a couple more signs. So there is a technique called transfer learning that you don't need to train your entire model again. So you're going to take advantage of Google already created, so these tasks, and what you're going to do is to train the last percentage of that model. So basically you're going to send 50 plus 100 images there, and you're just going to train for that last bit for the information that you want. So imagine that you want to train for playing rock, scissors and paper. Rock, paper and scissors, whatever. Imagine that you want to train for that specific game. You just need to train for these three specific data. So these three specific signs, these three specific gestures. You don't need to train your entire model, and you're going to have a high confidence on that model because it was already pre-trained by Google. And it's incredibly fast to do this. So once again, you've got already a set of features learned, so it has the victory sign. Now imagine that I wanted to train with hello, so just the hand like this. I'm going to pre-train it with new task, and it's going to be capable to understand what hello is. I'm just going to show you the code, really simple. So this is just a couple of lines, and with this you're going to add a new gesture. So the first thing is you're going to access your data set. You say that you want to transfer learning with the end data. So basically it's going to process that entire task. Basically you split the data in 80% and 20%. 80% is used for training, and 20% is used for validation. So in order to understand the accuracy of your model. Then you just define a set of parameters. In this case, I'm using all the default ones, and once you've set them, you just click on export the model, and a couple of minutes afterwards, you're going to have a new task. So this new task, you're going to import into your app again, and basically, once again, using Android tools, the next time that you're going to import it on your code, and the next time that you're going to run your app, it's going to say that it detected the wave gesture or the lower gesture in case you do this. Out of curiosity to do this, you also got gesture recognizer from MediaPipe, and you've got an interface here that is called onResults. That's the interface that I showed you before that has onResults or onError, which is triggered when a gesture is detected. So in this case, it would output something like hello. Next, you've got the dynamically one, and this is a bit more complex. So how does this work? So the dynamic one is capable to understand time. So it's capable to understand a wave in a distance, and you need to do something like this. So you already have your task for MediaPipe, and what you're going to do is to detect the landmarks on your movement. So basically here, you just need to call this unland marker, which is a function from MediaPipe, and you call the detect, and each image of the frames, it's going to retrieve the landmarks. So it's going to retrieve your X and Y positions and Z positions of each one of your end articulations. Then you set analyzer and you save it on a file. And this is what you're going to have. So a huge JSON file with the position of a waving that you did. You organize it on subfolders, you repeat it multiple times, and you export your databases. And then you're going to use something that's called TensorFlow with Keras that basically will allow you to train your model in a more complex way. Keras is an high-level API that reduces the friction of user TensorFlow, and it's allowing you to train models. And TensorFlow, for instance, allows to train your model and to run it TensorFlow Lite on your mobile phone. Now I'm going to do something that I shouldn't do, because there's a thing called the Murphy Law, where you should not do anything live, but I think it's important to show you how simple this can be if you use N-Train. So I'm going to try to do something here really quick. Let's see if the gods are with me in this one. I'm just going to close down this a bit. Okay. You can still hear me, right?
Yes.
Okay, so let's do something here. I've got my phone connected. And what I'm going to do here is, I've opened the app, and I think you can see this. I'm going to train it. I'm going to say here recipe, and I'm going to use 01 and save this. So I need to pause this here. Search Panda, can you come here, please? I need a stand. You just point it like this to me, okay? So I think you can wait, okay? So I'm going to click save, and I'm going to capture. Okay, so to save, it's to do a recipe, it's something like this. It's this gesture, and I'm going to do it over and over again. And I'm going to keep doing it. Sorry for this. Fine. Everything okay?
Fine.
Okay, so automatically I'm going to send it via Bluetooth to my computer. I think you can see it here. And I'm going to do it 2 more times. Already been sent. Now I'm going to call it Bluetooth. Okay, I'm going to capture again. Now I'm going to be a bit more on the back so it can understand that the landmarks can vary. And now I'm going to be a bit on the front. And hopefully the light is the right one. Okay, send it again. Okay, this final one. Ideally we should do these like 50 times. I think you want to watch another talk, so I'm just going to do this 3 times.
No, stay there, stay there.
Okay, thank you. So I'm going to send it again to my computer. I should have received it. Okay, so okay, I've arrived with it here. And so basically I'm just going to open one of the files, and you can see that I've got a lot of JSON files. These are my end coordinates and landmarks. I know that perhaps you cannot see that well, but it's like C, X, Y, and Z. What I'm going to do here is I'm going to unzip all of them, and I'm going to create a new folder called recipe. I'm going to move them here. I'm going to compress it, and now I'm going to, I've got here a none folder, and this none folder is just me doing nothing, because I always need to have the opposite. So if I'm doing this gesture, I also want the gesture of me doing nothing. So I'm going to compress none, and what I'm going to do here is, I've got, this is collab, okay? And basically this is expecting the data sets. So I've got none here, and now I've got a recipe that I've just recorded here. Almost there. The first thing that I'm going to do is to compile the data. So the data is already here, landmarks. Now I'm going to train my model. And once again, this should be done with 50 different sets of landmarks, and I'm just doing this with 3. The landmark is it's being trained here. This always takes a couple of seconds. The training is starting. And while it's training, I'm just going to return to the slides and just speak about the last thing while it's training. So I've created this to understand the gestures, but now there's an important thing, which is what I'm going to do with the gestures. You saw that I was requesting for weather, so I need to request an endpoint in order to use the weather. So there is 2 solutions for this that I'm really happy with it, which is called the GenKit and Cloud Functions. This is built in Firebase, and basically Cloud Functions is a serverless compute engine that you can have HTTP requests to ask for more information. So it can be used, for instance, for something like when a user logins in your app, you send a welcome email. On our use case, what I want is, I want to make a request and receive a response on Gemini quite friendly. GenKit allows me to define how this process is going to make. So this is a multi-step process. So if I receive a question about the weather, I'm going to receive, when I want a friendly response, I need to do a set of steps. The first one is I'm going to receive a request with latitude and longitude. The second one, I need to make a query to an external API. The third one is, with this information, I need to talk to Gemini for that response. So once again, a bit of code here just to show you how simple it is. I've created an interface here from the information that I want. This is running on Firebase, and once I receive this information, I make a query to OpenWeather API that's going to return a JSON with that information. And once I receive that information, I'm just going to make a prompt to Gemini in order to receive this information. I'm going to say that I recognize a gesture, for instance, the weather. These are the coordinates of that person, and the weather API returned this. And then I'm just saying, please write a natural phrase for an application that's going to be used by people that don't know, that don't speak. And then just saying this information back. I've got here the endpoint to make the call, and I'm just sending the information here. Now that this is trained, I'm just going to export it really fast. I'm going to just export this really fast. It's exporting my model. I've got it here. Okay, so I'm just going to download this model. And this model is the data that I've just trained. And And the way it works is, I've downloaded it. I need you again, sorry. So I downloaded it, it's here. I'm going to update the current one that I have. Overwrite, compile the app. Now just, okay. Okay, I think, okay.
Here is a classic, full preferência for incredibly tender and flavorful meatballs. Using the mix of meats and suging the bread.
Now it's a recipe for meatballs. Basically, I'm just, with the Portuguese accent, speaking in English. Yeah. So basically, you can see that it's easy to train with these already existing models. In this case, just trained the gesture recipe. I've connected to GenAI with the recipe of meatballs, and now it's already output of it. Thank you so much. Sorry for this.